being tutoring, Fort being tutoring, Fort being tutoring, tutormemath.net. Fort being tutoring, Fort being tutoring.
Fort Bend Tutoring. Math made easy. Personalized math tutoring is the solution. Here's Mr. Witt.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today we will be discussing a new lesson called Graphing the Tangent Function. Graphing the Tangent Function. All right, let's check it out. Here we have the tangent function, ladies and gentlemen, in its standard form. You have y equals a tan of bx minus c plus d. And we'll be getting those a, b, c, d values for these purposes. Number one, we'll find out that the absolute value of a is the vertical stretch. So the vertical stretch is going to stretch out our graph on our coordinate plane. And two, we'll be finding the period. That's going to be pi divided by b. This value is going to tell you the length of your function. Then you'll have the asymptotes. The asymptotes, ladies and gentlemen, are going to be unique to tangent and some of the other trig functions, because anytime you have 0 in the denominator of a fraction, you'll end up with an undefined result. So note that tangent is y over x, or the opposite divided by the adjacent value. So sometimes that x value will be 0. In those situations, you'll end up with an undefined result, which is why we have the equation bx minus c will equal to plus or minus pi over 2. The reason being is that at 90 degrees, you'll end up with 0 in the denominator. And at negative pi over 2, or 270 degrees, you'll also have 0 in the denominator, which is going to be an undefined tan result. So we'll be working with asymptotes, the areas on the graph where you cannot have any points when we're graphing our tangent function today. All right. Also, ladies and gentlemen, the d value is going to assist us with our vertical shift. That's going to slide our graph either up or down. All right. And then finally, the increments, ladies and gentlemen, is going to be the period divided by 4. The reason why we want the increments is to assist us in setting up our XY chart so that we can come up with more points to graph on the Cartesian plane, on the rectangular coordinate system. In other words, to help us graph the function. All right, so let's check out our first problem, ladies and gentlemen. But first, let me go ahead and show you that original standard form again for the tangent function. Y equals a tan of bx minus c plus d. That's what we'll be dealing with. We'll be getting our a value, b value, c value, and our d value to help us graph the tangent function. All right, let's see what's going on then. Problem number 1. I have here y equals tan x. So what I want to do, first of all, ladies and gentlemen, is I want to figure out all those values for a, b, c, and d to assist me in graphing the function. I know that the absolute value of a is going to give me my vertical stretch. In this function, my a value happens to be 1. So the absolute value of 1 is 1. And that's it. All right, that's that value. My period, ladies and gentlemen, is going to be pi divided by b. The b value is the coefficient of the x term here. So that b value in this case is going to be 1. So I'll end up with pi over 1, which simplifies to give me a value of pi. That's it. As far as the equations to set up my asymptotes, ladies and gentlemen, remember it's going to be that bx minus c value. And in this case, I just have the x term by itself in this function. So when I set up my asymptote, that bx minus c equals to plus or minus pi over 2, all I'll need to grab is just the x value right here, this x term. So let's set it up like this. I'll say that x must equal to plus or minus pi over 2. And that's going to be the equations for my asymptotes for this problem. I don't have a d value in the original function, so that means that my d value is 0. And then finally, in order to get the increments, those values that's going to assist me with filling out my XY chart, I'll need to find out the period divided by 4. So my period value, remember, is pi, so it's going to be pi over 4 to be my increments. All right, so let's highlight those values that we have thus far. We know that our vertical stretch is 1. We know that we have a period. The whole function length is going to be pi in length. I also know that my asymptotes will have the equation x equals to plus or minus pi over 2. I know that my vertical shift is 0. I won't be moving up or down to slide this function. And then I have my increments, which is pi over 4. That's what I'll be adding to each x value to get to the next one. We're going to start at our extreme left, ladies and gentlemen. So we'll be using the asymptote value of negative pi over 2. That's going to be the first value I need in my XY chart. So negative pi over 2. So negative pi over 2 plus pi over 4 is going to give me a result of negative pi over 4. Remember, we're using the increments to assist us with the XY chart. So we started out with negative pi over 2. I added pi over 4 to that, and that gave me negative pi over 4. And adding pi over 4 to negative pi over 4 gives me 0. Then adding pi over 4 to 0 gives me pi over 4. And adding pi over 4 to that gives me a result of pi over 2. Notice how we're ending up with that positive pi over 2 value. The total length, once again, of our period of the function is going to be pi, ladies and gentlemen. So notice that from negative pi over 2 to pi over 2, that gives us a total length of pi. All right. From there, we're going to be plugging in our x values into the original function of y equals tan x. So when I plug in negative pi over 2 into my function, tan of negative pi over 2 or tan of 270 degrees is going to give you a value that's undefined. So the y value is undefined when my x value is negative pi over 2. Remember, if you need some help in finding your trigonometric values, watch our video called Finding the 6 Trigonometric Function Values. All right, and that'll help you out with this. Then I'm going to be plugging in negative pi over 4. Plugging in negative pi over 4, which is also negative 45 degrees, which you could also say is 315 degrees. Tan of 315 degrees, ladies and gentlemen, is negative 1. So that's what I have there. When I plug in 0 into the function, tan of 0 is just 0. And pi over 4, that value is 45 degrees. And tan of 45 degrees, ladies and gentlemen, is positive 1. Finally, I'll be plugging in pi over 2. At pi over 2, tan is undefined. So I'll have it written as undefined here in my XY chart. Once we have completed the XY chart, you're going to plot those values, and we'll always start with our asymptotes. Remember that at negative pi over 2 here, our y value is undefined. That's going to be an asymptote. At pi over 2, it's undefined. That's another asymptote. So in other words, wherever you have an undefined value on your XY chart, that's going to be where your asymptotes will lie. So let's go ahead and graph that. At negative pi over 2, I'm going to show a dashed line to show that is where my asymptote is. That's where I cannot have any values on that asymptote there, on that dashed line. Then at pi over 2, I also have another asymptote. Okay. So it's going to look like this thus far. From there, ladies and gentlemen, we're going to plot the other 3 points that we have on our XY chart. We're going to have the negative pi over 4. That's going to give us a value of negative 1. So at negative pi over 4, I'm going to be at negative 1 here. All right. Then at 0, 0, that's my origin. I'll place a point. And then finally, at pi over 4, I have a value of 1. Now, ladies and gentlemen, this is never going to be a straight line inside between the two asymptotes. In fact, it's going to look similar to the graph of y equals x cubed inside of this area here. So that means that you're going to get close to your asymptotes as close as possible, and you're going to curve down like so. All right. So let me give you the full effect of that. So your graph will look just like this. If your teacher requests that you have more than one period on your graph, all you have to do is just repeat this process either to the left or the right. For instance, if I have a total length of pi between my asymptotes, all I have to do from pi over 2 is to go another pi in length. So pi over 2 plus pi gives me a result of 3 pi over 2. So that means that I have an asymptote also at 3 pi over 2. All right. So that's the way that looks. Then I can put in the 3 points that I have here in between, which means that at 3 pi over 4, I'll have a value of negative 1. At pi, I should have a value of 0. And at 5 pi over 4, I have a value of positive 1. And once again, I'll use that same snake-like move to plot that function in between the asymptotes. So that repeats that period there. And you can do that also to the left as well, or to the right if you choose, depending on how many periods your teacher requests. So once again, ladies and gentlemen, the graph of y equals tan x, we just did that. We had our XY chart. We filled out the value for the vertical stretch. We also found our period that had a length of pi. We found out the equations of our asymptotes, which is going to be x equals to plus or minus pi over 2, using the formula bx minus c equals to plus or minus pi over 2. We also found out that in this equation, our vertical shift is 0, that d value. And then we used our increments, that period divided by 4, which equal to pi over 4. That helped us find the other values on the XY chart that we needed to use to graph. All right, so let's continue on, ladies and gentlemen. We are on problem number 2 now. Okay, here we are. Let's straighten this out. There we go. All right, I have y equals tan of x minus pi. Y equals tan of x minus pi. So here, ladies and gentlemen, once again, we'll start with the absolute value of a. Our a value in this function is 1. So I'm going to have the absolute value of 1 equals to 1. That's it. Moving on to the period. Remember, the period is going to be pi divided by b. Your b value is always the coefficient of your x term. So in this case, I'll have pi over 1, which just gives me a value of pi. Next, for my asymptotes, all right, I'll use bx minus c equals to plus or minus pi over 2. So plugging in this bx minus c value here, that x minus pi, all right, I'll be using that as my bx minus c. So therefore, the equation is x minus pi equals to plus or minus pi over 2. So this will be the equation that you solve for. When you solve for x, ladies and gentlemen, in this problem here, you'll end up with 2 values. Those 2 values will be pi over 2 as well as 3 pi over 2. So those are the results of the equation x minus pi equals to plus or minus pi over 2. We'll end up with pi over 2. That'll be our starting point. And 3 pi over 2, that'll be our end result. In other words, those locations are where the asymptotes will lie on our graph. For this equation, ladies and gentlemen, your vertical shift, that d value, is 0. We don't have an additional value up here in the function. So that's going to be 0 for d. Finally, for the increments, that period divided by 4, remember that our period is pi, so we'll end up with pi over 4 for our increments. So once again, I'm going to highlight those values that we just got. All right, I know that my vertical stretch is 1. I know that my period length is going to be pi. I know that my equations for the asymptote are going to be x equals to pi over 2 as well as x equals to 3 pi over 2. I know that my vertical shift is 0, so I won't be sliding up and down the graph in this one. And I also know that my increment, what's going to help me get other values on the XY chart, is going to be pi over 4. So these are the values that I have thus far. From here, ladies and gentlemen, we're going to go ahead and fill out our XY chart, starting with the value of pi over 2. Remember that we're going to start with that first. So I have my first value, which is pi over 2. I then have 3 pi over 4 because I'm adding pi over 4 each time. Then I have a value of pi. The next value is going to be 5 pi over 4. I'm adding pi over 4 each time, ladies and gentlemen, because of the increments. And then I end up with 3 pi over 2. So these are going to be the 5 values that I use for my XY chart. From there, we're going to plug in pi over 2 into the original equation. So plugging in pi over 2 for x, I have pi over 2 minus pi. That's going to give me a value of negative pi over 2. And at negative pi over 2, which is the same thing as 270 degrees, your tan value is going to be undefined. So that's going to be the y value for pi over 2. When I plug in 3 pi over 4, 3 pi over 4 minus pi gives me a value of negative pi over 4. Well, negative pi over 4, ladies and gentlemen, is negative 45 degrees, which is 315 degrees. At 315 degrees, your tan value is negative 1. Plugging in pi into the original function, we have tan of pi minus pi, which is going to be tan of 0. At 0, your tan value is 0. Then plugging in 5 pi over 4, I have 5 pi over 4 minus pi, ladies and gentlemen. That's going to give me a value of pi over 4. Tan of pi over 4, or tan of 45 degrees, is positive 1. Finally, when I plug in 3 pi over 2 into the original equation, 3 pi over 2 minus pi gives you a value of pi over 2. Tan at pi over 2, or tan at 90 degrees, is undefined. All right, so that's going to complete our XY chart. So the next thing we need to do is to graph it. Remember, we're going to start with our asymptotes first, okay? I know I have an asymptote at pi over 2. I also have a asymptote at 3 pi over 2. So let's start by graphing that on our rectangular coordinate system first. All right, so at pi over 2 is where I have a asymptote. And at 3 pi over 2, I also have another asymptote. All right, like so. So it's looking like that thus far. Then, plotting the other 3 points that I found, at 3 pi over 4 on our graph, we'll be at -1. Let's start with that value. So 3 pi over 4, I'm at -1, so I have a point right there. Then, at pi, I'll be at 0. Next, at 5 pi over 4, I'll be at +1. And what I'll do next, ladies and gentlemen, remember that snake-like move here. We're going to graph through these points. So it's going to look just like this. All right, between our asymptotes, and this is going to be the final result here. All right, so once again, ladies and gentlemen, after using our XY chart, we'll go ahead and plot those values on our rectangular coordinate system. And there's going to be the end result, that snake-like move between the asymptotes. Once again, if you need to repeat that process either to the right or the left, you'll just use that same pattern that you have within that. You'll just duplicate that. All right, that completes problem number 2. In our next example, we have y equals to -2 tan x plus 1. -2 tan x plus 1. We want to once again find out those values that I showed you on that front page, okay? So let's find out the absolute value of a. The absolute value of a in this case is going to be the absolute value of -2, which is going to give me a result of +2. My period is going to be pi over b. So here I end up with pi over 1, which gives me a value of pi. All right. For the asymptotes, we'll have the equation bx minus c equals to plus or minus pi over 2. So in this equation, ladies and gentlemen, my bx minus c amount is going to be just x. All right, so that bx minus c amount equals to plus or minus pi over 2. That'll be x equals to plus or minus pi over 2. And this is going to be the equations for my asymptotes. In this equation, this function, we have a d value of 1. So what we'll do is we'll show that our vertical shift is going to be 1 in this case. Finally, the increments, we'll find that by dividing the period by 4. So I'll have it set up as pi over 4 here. So once again, I'll be highlighting those values that we found. We found out that our vertical stretch is going to be +2. Our period is pi. Our asymptote equations is going to be x equals to plus or minus pi over 2. We'll also have a vertical shift of +1. And I know that my increments is going to be pi over 4. So these values are going to assist me in graphing the function, ladies and gentlemen. All right. Remember, we always start with the extremes of our asymptotes here. So that means on my XY chart, I'll be starting with -pi over 2. Then I'll have the value of -pi over 4. Next, I'll have 0, then pi over 4. And finally, I'll end up with pi over 2. Okay. So once I have these 5 values, I'll be plugging that into my original equation, the original function. So plugging in -pi over 2 here into the original function, tan at -pi over 2, or tan of 270 degrees, is going to be undefined. So if this amount is undefined, the whole thing is undefined. So we'll end up with an undefined amount for y for that -pi over 2 value. Next, I'll be plugging in -pi over 4. Well, that's going to be tan of 315 degrees, ladies and gentlemen. And there, at that location, you'll end up with a tan value of -1. So -1 times -2 is +2. And then 2 plus 1 gives me a value of 3. All right, that's an ugly 3. Let's fix that. There we go. It's kind of ugly, but we'll keep it. Yeah, we'll keep that. Then plugging in 0, I'll have tan of 0, which is 0, and 0 times -2 is still 0, and then 0 plus 1 is 1. So that's my value there. Plugging in my next value of pi over 4, tan at pi over 4, or tan of 45 degrees, is positive 1. 1 times -2 is -2, and then -2 plus 1 gives you a result of -1. Finally, at pi over 2, tan at 90 degrees, ladies and gentlemen, is undefined. So that means the entire function is undefined at that point. All right, so completing our XY chart, we'll go ahead and graph it. Let's start with asymptotes. We have an asymptote, ladies and gentlemen, at negative pi over 2. We also have an asymptote at positive pi over 2. All right, so thus far our graph looks just like this. Then graphing the other 3 values that we have, at negative pi over 4, we know that we're going to have a y value of 3. So negative pi over 4, I'll be at 3. Then at 0, I'm going to have a value at 1. And then at pi over 4, I'll have a value at -1. Okay, so I'll be writing it like this with a snake-like move. All right, so due to that vertical stretch, ladies and gentlemen, our graph has been stretched out there. So remember, even though it's stretched out, you still want to have a snake-like curve here when you're graphing that tan function between your asymptotes. All right, so keep that in mind, ladies and gentlemen. Because of the vertical stretch, that's why our points are separated like this. Also, keep in mind that we had a negative value at the beginning. What that did for the graph is that reflected it, ladies and gentlemen, that flipped it around. It reversed the function as far as the graph is concerned. Normally, we come from the right and then we go to the left. In this case, we came from the left and we ended up at the right. All right, that completes problem number 3, ladies and gentlemen. All right, let's move on to the next. This is going to be our last and final problem for this lesson today. In problem number 4 here, I have y equals to negative tan x minus 1. We're going to start by finding out the vertical stretch, that's the absolute value of a, by looking at the absolute value of -1. Well, the absolute value of -1 is positive 1. Then, going for my period, I end up with pi over 1, that b value, so that gives me a period of pi. Then I have my asymptotes, which is going to be bx minus c equals to plus or minus pi over 2. So for that equation here, my bx minus c amount is just x. So I'll be able to find the equations for the asymptotes by writing it as x equals to plus or minus pi over 2. Plus or minus pi over 2. Then my d value for this function is going to be -1. And my increments will be found by finding the period divided by 4. So that's going to be pi divided by 4. These 5 values that we have, ladies and gentlemen, this positive 1, this pi value, the equations x equals to plus or minus pi over 2, as well as my vertical shift of -1 and the increments of pi over 4 are going to be the values that assist me during the graph. So starting with my asymptote values, I'll start on the XY chart with negative pi over 2. In order to get the other values, you keep adding pi over 4. So that means I'll have negative pi over 4. I'll also have 0, pi over 4, as well as pi over 2. Plugging these values back into the original function here, I'll have tan of negative pi over 2, which is 270 degrees. That's going to be an undefined amount. So if any part of your equation is undefined, the whole thing is undefined. All right? Then plugging in negative pi over 4 or negative 45 degrees, tan at 315 degrees, which is also the same thing, is going to be -1. -1 times -1 is positive 1, and then 1 minus 1 gives me a value of 0. Plugging in 0 into our function, we have tan of 0, which is 0, minus 1 gives me a -1 value. Then I'll be plugging in pi over 4 into the original function. Tan at pi over 4, ladies and gentlemen, or 45 degrees, is positive 1. 1 times -1 gives you a result of -1, and then -1 and -1 combine to give you a value of -2. So we have -2 here on our XY chart. Finally, I'll be plugging in pi over 2. Tan at pi over 2, which is 90 degrees, is undefined. So here, my y value is undefined at pi over 2. So let's start once again by graphing our asymptotes. We have an asymptote at negative pi over 2. So I'll do my dashed line here to show that area can't be touched. And then I also have pi over 2 with an asymptote. From there, I'll be plugging in these three values in between. So starting at negative pi over 4, I'll be at 0. Then at 0, I'm at negative 1. Then finally, at pi over 4, I'll be at negative 2. So now all we have to do is draw our snake move through these three lines. We'll have our graph snaking through those 3 points, and I'll end up with a tan graph that looks just like that for that function. So the graph of y equals to negative tan x minus 1 looks just like this between our two asymptotes, ladies and gentlemen. So make sure you're always putting a snake move through your points within the asymptotes. All right, so that concludes this problem, ladies and gentlemen. All right, we graphed our XY chart. We have the graph of negative tan x minus 1, which meant that we were shifted down 1, and we had that reflection because of the negative in front of the function. So, ladies and gentlemen, I hope you enjoyed this lesson. Once again, this was graphing the tangent function with Mr. Witt and Fort Bend Tutoring. As always, please rate, comment, and subscribe. We appreciate everything that you do as far as the interaction is concerned, and feel free to join in on our intros and outros, ladies and gentlemen. We're looking forward to seeing some of those from you guys by sending your audio or video file to fbt@tutormemath.net. Once again, this is Mr. Witt with Fort Bend Tutoring. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry, pre-cal, calculus, can't forget